A PN junction forms the basic building block of many semiconductor devices like diodes, transistors, etc. We will try to understand the structure and working of a PN junction. PN junction is an interface or a boundary between two extrinsic semiconductor materials, the P type and N type. The P side contains excess of holes and N side consists of excess of electrons. We shall now try to understand how a PN junction is formed and its internal mechanism. A small quantity of pentavalent impurity is added to a thin P-type semiconductor wafer. Let's call it P-silicon. Thus, part of P-silicon wafer is converted into N-silicon. The wafer will thus contain a P region and N region and a metallurgical junction between P and N regions. Let's now discuss some important terms in PN junctions. Diffusion current. Holes diffuse from P side to N side and electron diffuse from N side to P side. This motion of charge gives rise to diffusion current across the junction. The next one is depletion region. When electrons diffuse from N region to P region, it leaves behind ionized donor, that is positive charge on the N side, which is immobile. Thus, a layer of positive ions is developed in the N side. Similarly, a layer of negatively charged ions are left behind on the P side. In other words, this movement of electrons and holes across the junction depleted the region of free charge to form immobile ions. Hence, this region is known as the depletion region. The thickness of depletion region is of the order on 1/10 of a micrometer. Next, let's discuss drift current. Due to the positive space charge region on N side of the junction and negative space charge region on the P side of the junction, an electric field directed from positive charge towards negative charge develops. Because of this electric field, electrons move from the P side to the N side of the junction and hole moves from N side to the P side of the junction. This motion of charge carriers due to the electric field is known as drift. Thus, the drift current is in the opposite direction of diffusion current. Initially, diffusion current is larger than drift current. But as the diffusion process continues, the space charge region on either side of the junction extends, thus further strengthening the electric field strength and hence drift current. This process continues until diffusion current equals drift current. Finally, a PN junction is formed. The net current in a PN junction under equilibrium is 0. Next thing we should discuss is barrier potential of a PN junction. Due to loss of electrons from N region and gain of electrons in the P region, a potential difference develops across the region. The polarity of this potential is such as to oppose the further flow of carriers such that equilibrium exists. This potential opposes the movement of electrons from N region to P region and hence it is called the barrier potential. Now let us summarize what we have seen so far.
Manorama Horizon. Learning made simple.